In 2025, many programmers are asking the same question: will AI replace us? Let's be real. If you try to compete with AI, you'll lose. But if you work with it, you'll move faster than ever before. Now, I don't know about you, but I tend to avoid tedious programming tasks. Writing documentation, refactoring old code. I usually take way more time than needed. Not because it's difficult, but because I simply lack the motivation. I'd rather dive into exciting new ideas than get stuck in boring chores. And that's exactly why I decided to build myself a personal coding assistant. Hello everyone, welcome to Debugging with K Tips. If this isn't your first time here, welcome back. I've spent the last couple of days developing a coding assistant. Yes, I use ChatGPT and its siblings, but there's a problem: they can't directly access my codebase. I needed something free, open source, and secure, something that could run locally on my own machine. Of course, not everyone has the resources to run large AI models locally. But the good news is, in 2025 many companies and dev teams rely on cloud-based setups, and guess what? My assistant works there too. The tool I'm showcasing today is AgentSculptor, an experimental project I built during the OpenAI Open Model Hackathon. Right now, it's been tested mainly with GPT-OSS 120B via VLLM. Other models may also work, but compatibility isn't guaranteed just yet. Use it at your own risk, and if you try it with different setups, I'd love to hear your feedback. So, enough talk. Let me show you what happens when you ask AgentSculptor to create a Dockerized FastAPI app from scratch. Before we dive into the demo, a quick note: you'll find a link in the description to the GitHub repo. There you'll get the full source code as well as installation instructions. You can install AgentSculptor directly from PyPI, or if you prefer, you can install it from source. Both options are explained step by step in the README. One important requirement: AgentSculptor needs Python 3.12. Make sure you have that version installed, otherwise you may run into compatibility issues. Once the installation is successful, there's just a little bit of setup. You'll need to define two environment variables in your operating system. VLLM_URL, this points to the running VLLM service. VLLM_model, the model you want AgentSculptor to use. With those variables set, AgentSculptor is ready to run. And that's when the fun begins. So first, I told AgentSculptor where my project codebase lives, in this case, a folder called test_project. Then, I gave it my instruction in plain English: create files for a basic Dockerized FastAPI application. The initial app should just return a JSON with "hello" to the OpenAI community. No YAML configs, no boilerplate, no copy-pasting code snippets from tutorials. Just a simple natural language instruction. And from there, AgentSculptor figured out the exact steps it needed to take, asked me for confirmation, and built out the whole project structure automatically. As we can see, my folder test_project is empty at this stage. First, AgentSculptor asked me, "Do you want me to create a main.py file?" I typed yes, and it created it. Then it asked about a requirements.txt. Again, I said yes, done. Next up, should I generate a Dockerfile? Absolutely. Created. Finally, it suggested adding a test file, test_main.py. I approved, and it wrote that one too. Step by step, file by file, AgentSculptor built out the entire skeleton of a Dockerized FastAPI application, exactly as I described in my prompt. And when everything was ready, it stopped on its own, because the task was complete. Now let's explore the created files, starting with the Dockerfile. Those of you familiar with Dockerfiles and FastAPI applications may notice that this one is well structured. This Dockerfile builds a lightweight Python 3.11 container, installs the app dependencies, and copies the application code into /app. Finally, it exposes port 80 and runs the FastAPI app with Unicorn, making it production ready out of the box. Now let's continue by looking at the main.py file. This file sets up a basic FastAPI application. It creates an instance of the app and defines a single route at the root URL, /, which responds with a simple JSON message, "Hello to the OpenAI community." It's a minimal, working example of a fast API server that's ready to handle HTTP GET requests. And remember, the JSON output is exactly what we instruct the LLM to return. But wait, in the application, we import FastAPI from the FastAPI library, and in the Dockerfile we use Unicorn. That naturally leads us to think about dependencies. AgentSculptor provides a requirements.txt file, which lists the packages needed to run the app. For instance, it includes FastAPI and Unicorn standard, which are also used in the Dockerfile. Here, GPT-OSS 120b demonstrated its high reasoning competence. And my absolute highlight is the test_main.py. This code sets up a simple test for a FastAPI application using the built-in test client. It imports the app instance from main.py and wraps it with test client, allowing HTTP requests to be simulated without running a real server. The function test_root sends a GET request to the root URL, /. It then checks that the response status code is 200, meaning the request was successful. Finally, it verifies that the return JSON matches the expected output with the message, "Hello to the OpenAI community." Let's try to run it. It fails. Do you know why? Let me know in the comments. I think I should have asked AgentSculptor to provide a README with clear instructions on how to run it. That's it for this video. Feel free to check out my other video on how to set up a Python web app in a Docker container. The link will pop up now. If you found this video helpful, leave me a thumbs up. Don't forget to subscribe, like, and share. Thanks for watching. Happy coding and debugging with K-Tips. See you in the next one.